In this video, we'll have a look at a new cutout subassembly that will allow us to make cutouts, parametric cutouts, in any of the faces of a cabinet box. So if we go, the easiest way to see this subassembly at work is probably through the edit design data. So I'll just show you where we can find it. If we go into through the subassemblies, you'll see it's possible to insert it this way as well. So if you wanted to insert it in here, we can insert it from cabinet modifiers cutout. It's just a little easier to explain the functionality from inside the spreadsheet because it is designed to be used as a parametric item that you would put into a library product. So here, if we go to our subassemblies, what I've done is created one of each of the different types of cutouts. And so in this subassembly, the way it works is basically the width, height, or depth. Any combination of the two of those, depending on where it's located, is going to define the size of the cutout. And then the X, Y, and Z origin are going to define the center point of that cutout. And so here, if we look, what I've done is create 5 different lines. If we look in the drawing here, I've just illustrated that the bay position numbers. So for the left side, it's bay position 1, right side is 2, and so on and so forth. So here you can see I've set up the dimensions of those cutouts accordingly. So for a cutout on the left side, I'm only using a height and a depth. There is no width for that cutout. Same thing for the right. For a cutout in the top and bottom, it's only a width and a depth. And for a cutout in the back, it's only a width and a height. And then the origin is a point, just like if it was a associative piece of hardware. It's the center point of that cutout, and including the minus 0.01 in order to push it into the panel that you want to cut that cutout into. So if I turn all these on, just to show you how that works, we can redraw the product. And so there you can see that those cutout sub-assemblies are making these different size cutouts in that product based on the location and sizes set on the subassembly items, with the bay positions determining which way they go. Just as a check in future, so you can see which face those cutouts happen on, you can just go into the subassembly file, and on the lookup tables you can see where those bay positions are actually located. So those are the bay numbers, and that's the location in the cabinet where that machining is done. And you can see there are prompts for things like radius corners and the size of that radius, and then these ones are all just calculating based on the bay position. So if you're entering this from the part properties, then you could just come into the subassembly prompts and hard code those. But in general, this is probably going to be used more for creating cutouts parametrically in cabinet parts.